The most dangerous thing about the eruption that just happened in the South Pacific isn't the 54,000-foot wall of ash it punched into the stratosphere, it's the fault sitting directly underneath it. Ambae volcano in Vanuatu erupted yesterday, and it happens to sit on top of one of the most active megathrust faults on Earth, a fault capable of a magnitude 8 earthquake and a tsunami that could cross the entire Pacific. Officials in Japan are already checking whether a wave could reach their coastline. Stick around, because by the end of this, you'll understand exactly what that fault is capable of. Yesterday morning, a volcano in the middle of the Southwest Pacific threw a column of ash 54,000 feet into the sky. That number alone is the story. Let me put it somewhere you can actually feel it. 54,000 feet is a little over 16 kilometers straight up. The airliners you fly in cruise between 35,000 and 40,000 feet. This ash cloud punched through that entire layer of air traffic and kept climbing another 14,000 feet past it, straight into the stratosphere. That's the altitude band reserved for the most violent eruptions on the planet, the kind that can shut down airspace across an entire ocean basin. The volcano is called Ambae. You might also see it written as Auba. It sits in the northern islands of Vanuatu, a chain east of Australia in the Southwest Pacific, and in the global volcano catalog, it's listed under number 257030 at 9:40 a.m. Local time yesterday, it produced the single largest explosive pulse of an eruption that's actually been simmering all year. The Wellington Volcanic Ash Advisory Center, the aviation authority responsible for warning pilots in this part of the Pacific, measured the top of the cloud at flight level 540, aviation shorthand for 54,000 feet. An hour later, it had settled slightly to 50,000 feet, still one of the tallest ash columns recorded anywhere on Earth this year. And this measurement isn't a guess from someone on the ground. It came from Himawari 9, the Japanese satellite that watches this part of the Pacific around the clock. So this is a satellite-verified, publicly logged number, and everything unsettling about this story flows from how extreme it is. Here's why volcano watchers sat up the moment this crossed the wire. For most of the last month, Ambae had been doing something far more modest. Through late July and August, it was throwing ash to 10,000, 15,000 feet. July 30th, roughly 3 kilometers, about 10,000 feet. August 4th, about 4 kilometers, roughly 15,000 feet. August 16th, back down to around 10,000 feet. Steady, persistent, a little irritable, but routine for a volcano mid-eruption. Local hazard authorities were logging continuous tremor and a steady exhale of steam, gas, and ash. Nothing said catastrophe. Then, in a single pulse, the column jumped from 15,000 feet to 54,000 feet. That's not a gradual climb, that's an order of magnitude jump in how high this volcano is throwing material, and because eruptive energy scales even faster than column height. The actual power behind this eruption grew far more than the numbers alone suggest. In a matter of days, Ambae crossed the line between background activity and a major explosive event. When a volcano makes a leap like that, something changed underneath it. And the question that follows immediately is whether this is a one-time burst or the opening move of something bigger. Think about what it actually takes to loft ash that high. To reach the stratosphere, a volcano needs a jet of gas and rock energetic enough to punch through the entire lower atmosphere and stay buoyant the whole way up. Weak eruptions can't do it. Their plumes stall a few thousand meters up and drift sideways. 16 kilometers straight up requires enormous, sustained force. And that force is a direct readout of how much gas is escaping the magma and how violently. A taller column isn't just a taller column, it's the visible signature of a far more powerful eruption. That height also changes who's at risk. At cruising altitude, volcanic ash is invisible to pilots and lethal to jet engines, since the fine glassy particles melt inside them and can cause flameouts. A cloud sitting at 54,000 feet and drifting east and southeast becomes a hazard to every flight path across a wide stretch of the Southwest Pacific, which is exactly why an aviation authority, not a local emergency office, is the one issuing the official numbers. All of that follows from where this volcano happens to sit and The setting is what turns a dangerous eruption into something bigger. To understand why Ambae can escalate this fast, look at what's happening at the summit. Ambae is a basaltic volcano, and its magma is what geologists call primitive alkali basalt, unusually rich in dissolved gas. That gas is the fuel, but the trigger for these particular explosions is water. At the summit, inside the youngest caldera, sits a cluster of crater lakes, and the active one is called Lake Vui. When hot, gas-charged basaltic magma rises into direct contact with that lake water, the water flashes to steam almost instantly. That flash is explosive. It shatters the magma into fine ash and blasts the whole mixture skyward. Volcanologists call this a phreatomagmatic eruption. Magma meeting water. It's Ambae's signature move, and it produces far-traveling fine ash, acidic gases, acid rain downwind, and Lahar's fast-moving volcanic mud flows that form when loose ash mixes with lake water and rainfall and comes rushing down the slopes. A 54,000-foot column at a lake-filled basaltic volcano like this one tells us either the water interaction just became far more violent, or the eruption is shifting toward a more sustained, gas-driven style where the magma itself is doing more of the work. Either way, it points in the same direction, up. The fallout reaches well past the summit. Acid rain from a phreatomagmatic eruption strips crops bare and contaminates the rainwater catchments island communities rely on for drinking water. One practical reason. An escalation here forces evacuations, even when no lava is anywhere near a home. Fine ash coats gardens, chokes water supplies, and can pile up heavy and wet enough to collapse roofs. And lahars don't need the eruption to keep going. A slope loaded with fresh ash, hit by the tropical rain that's routine in this region, can send a wall of mud and rock down a valley days after the eruption itself has quieted. The danger from yesterday's pulse doesn't end when the ash stops climbing. It lingers in everything left behind. Now here's the part most coverage of this eruption is going to miss, because you can't see it in a photo. The green island with a smoking summit you'd see in a picture is only the tip of the mountain. Ambae is the single most voluminous volcano in the entire New Hebrides archipelago, an enormous basaltic shield estimated at roughly 2,500 cubic kilometers once you include everything below sea level. The visible summit stands about 1,496 meters above the water. That's only the top sliver of a mountain whose real bulk sits hidden on the seafloor. The summit is capped by nested calderas, collapse craters inside collapse craters. The outer structure spans roughly 12 kilometers with a 6-kilometer caldera nested inside it. And within the youngest of those sits the pyroclastic cone holding the 3 summit lakes, including Lake Vui. Those nested calderas are scars from past collapses, the geological record telling us plainly what this mountain is capable of when pushed hard enough. I'm walking through this architecture for a reason. A large, mostly submarine volcano with a broad caldera is exactly the class of mountain where scientists have to keep an eye on the possibility of flanks or crater walls giving way. When a volcano is mostly underwater, its slopes are supported by the surrounding sea, and a violent eruption, a sudden withdrawal of magma, or a strong earthquake can destabilize those slopes in ways that are difficult to see coming and difficult to monitor. Nothing in the current data says that's happening at Ambae right now, and I want to be careful not to imply otherwise. But the shape of this volcano is exactly why an eruption here draws a different kind of attention than one at a tidy little cone on dry land. A massive, mostly submerged pile of rock sitting in deep water is a structure whose failure modes involve the ocean itself. And that attention went international within hours. Before we get to the fault, you need to understand what an escalation at Ambae actually means for the people who live on it. Because this isn't hypothetical for them. They've had to run before. In 2017, during an earlier eruptive crisis, authorities evacuated the entire island, roughly 11,000 people, until the volcano calmed enough for them to return that October. Then it happened again. In April 2018, a state of emergency was declared, and by late July, the government ordered a full mandatory evacuation of the whole island, around 10,000 people. In early August, evacuations began ferrying residents to the neighboring islands of Mayo, Pentecost, and Espiritu Santo. So when yesterday's ash column jumped to 54,000 feet, the stakes weren't abstract. This is a community that has already been forced to abandon its own island twice in the last decade. And whether they'll have to do it a third time is sitting there, unanswered, as the eruption intensifies. That question gets sharper when you look at the one official number that didn't move. Vanuatu rates its volcanoes on a scale from 0 to 5. All year, through this entire ongoing eruption, Ambae's alert level has been held at 3, minor to moderate eruption. For weeks of 10,000 and 15,000 foot plumes, that description was fair. But a 54,000 foot stratospheric column is not a minor to moderate event. It's a far more energetic eruption than that baseline implies. That's not necessarily anyone's failure. An alert level describes the hazard on the ground, and column height is measured a different way entirely. But it raises a real, uncomfortable question. Whether the official alert level and what the satellites are actually recording are about to diverge, and how fast the people responsible will move if the eruption keeps climbing. And that gap matters so much here because of the ground this volcano is standing on. This is the part the title was pointing at, and it's the reason this eruption is more than a spectacular photo. Ambae sits inside the Vanuatu Island Arc, also called the New Hebrides Arc, and directly underneath that arc runs the Vanuatu Subduction Zone, one of the most dangerous fault systems on the entire planet. This is a convergent plate boundary where the Australian plate is being forced down beneath the Pacific plate. Standard scientific references describe this boundary as one of the most active subduction zones on Earth, rated as capable of producing great earthquakes of magnitude 8 or larger with the potential to send tsunamis across the whole Pacific Ocean. And this boundary moves fast. In places along this arc, the plates converge at more than 100 millimeters a year, several times faster than the long-term slip rate of the San Andreas Fault in California. A fast-converging, highly active megathrust is a fault-loading strain quickly, and the faster a fault loads, the more often it has to release that strain in a large earthquake. This is the fault sitting directly beneath the volcano that just erupted into the stratosphere. That's the collocation at the heart of this story, and it's worth being precise about what it does and doesn't mean. The volcano and the fault aren't two unrelated hazards that happen to share a neighborhood. They're both products of the same subducting slab. As the Australian plate dives beneath the Pacific plate, it drags on the boundary above it, which is what loads the megathrust. It also sweats water and melts into the mantle above it, which is what feeds the magma-building volcanoes like Ambae. The earthquakes and the eruptions in this arc are siblings born from one process. That shared parentage is real science, and it's the honest core of why this eruption is unsettling. A stratosphere-reaching eruption sitting on top of a fault flagged for a great tsunami-generating earthquake in the same place at the same time, driven by the same machine. And this region has been reminding everyone lately exactly what that fault can do. This isn't a sleepy fault scientists worry about. Only in theory, it's been actively breaking. On March 29th of this year, a magnitude 7.3 earthquake struck Panama province, causing injuries and extensive damage on Espiritu Santo, the very same northern Vanuatu region that contains Ambae. Go back further to December 2024, and a magnitude 7.3 earthquake struck near Port Vila, the capital, killing 14 people, injuring hundreds, and causing damage running into the hundreds of millions of dollars. The deeper history is worse still. Since 1900, this arc has produced roughly 2 magnitude 8+ earthquakes and dozens of magnitude 7 events, including the 1999 Pentecost earthquake magnitude 7.5, which generated a local tsunami with wave run-up of several meters and killed people. This is a coastline that keeps rupturing, driven by that fast-moving slab underneath. Notice the pattern. A damaging magnitude 7 near the capital in late 2024, another magnitude 7 inches, the exact province containing Ambae this past March, and a 100+ year history that includes great earthquakes and deadly tsunamis. This isn't a fault that might someday become dangerous. It's dangerous right now on a human timescale, and it's been actively proving that in the months leading up to this eruption. That same subducting slab is the engine behind both the earthquakes and the volcano. The magma feeding Ambae and the strain loading that megathrust are two faces of one tectonic machine, which is exactly why yesterday's eruption raised a question that reached all the way across the ocean. Because once you have a violent eruption at a mostly submarine volcano, sitting on a fault like this, in a region with this seismic history, someone is going to ask about a wave. Within hours of the eruption, according to Chinese state broadcaster CGTN citing Japanese media, authorities were investigating whether this eruption could send a tsunami all the way to Japan, thousands of kilometers to the north, a volcano in Vanuatu, and officials in Japan checking their coastlines. I want to be very clear here because this is exactly the kind of claim that gets distorted online. Right now, that's an investigation, a precaution. It is not a confirmed tsunami. There is no basin-wide wave verified as heading anywhere. But the fact the question was even asked isn't paranoia, and to understand why, you need to remember January 2022. That's when the Hunga Tonga volcano, sitting roughly 2,000 kilometers southeast of Vanuatu, in this same broad stretch of the Southwest Pacific, produced one of the most violent eruptions of the modern era. Its column reached the stratosphere and beyond, into the mesosphere, and it did two things at once. It generated a tsunami that crossed the Pacific, and it launched an atmospheric pressure wave that circled the entire globe, driving strange sea level oscillations thousands of kilometers from the volcano. In Japan, an ocean-away tsunami-like waves of around a meter were observed. The Japan Meteorological Agency issued tsunami advisories and warnings, and evacuation advisories reached large coastal populations. That single event rewrote the rulebook. Before it, the working assumption was simple. To threaten a distant coast, you needed a great earthquake, because only an earthquake moved enough water. Hunga Tonga broke that assumption in an afternoon, showing a volcano could do it two different ways at once, through the water and through the air, with effects arriving on the far side of an ocean before anyone fully understood what had happened. So, when a major eruption happens in this region now, checking whether a wave could travel isn't alarmism. It's the responsible move, and it's a lesson written in very recent memory. It helps to understand how a volcano generates a tsunami at all, because the mechanism is completely different from an earthquake's, and that difference is what makes these waves so treacherous. An earthquake tsunami comes from the seafloor suddenly lurching up or down and shoving the entire water column with it. A volcanic tsunami can come from several different sources instead. A submarine or coastal explosive blast directly displacing a huge volume of water, a caldera or flank collapse dumping an enormous mass of rock into the sea, pyroclastic flows pouring into the water and pushing it, or the atmospheric mechanism Hunga Tonga demonstrated, where the pressure wave itself drives the ocean a so-called meteote tsunami. There's another reason volcanic tsunamis are so dangerous, and it's about warning time. An earthquake announces itself with a seismic signal that races through the planet at the speed of sound in rock, reaching warning centers minutes before the wave itself moves anywhere. A flank collapse or underwater blast produces little or no clear earthquake signal, so the wave can be generated silently. And the first sign anything is wrong can be the water pulling back from shore. That inversion, where the eruption itself is the only warning you get, is what makes this category of hazard so hard to defend against. And it's exactly why officials investigate early rather than waiting for confirmation that might arrive too late to act on. Remember, Ambae is largely a submarine volcano with a broad caldera, precisely the class of volcano where water interaction and flank stability matter, even though nothing in the current data indicates a collapse is underway. History holds the warnings. Anak Krakatau in December 2018 suffered a flank collapse that generated a tsunami killing more than 400 people in the Sunda Strait, with essentially no earthquake warning at all, because the seismic signal from a collapsing volcano is weak, or absent the wave simply arrived. And Krakatau itself, back in 1883, produced tsunamis that killed tens of thousands and registered on tide gauges around the world. These are the reference points that turn a question about Ambae from science fiction into a reasonable precaution. But a precaution is all it is today, and the honest thing to do is say so plainly. So where does this leave us this morning? The most defensible reading is this. Ambae has entered a markedly more energetic phase of an eruption that was already ongoing, throwing ash into the stratosphere and forcing the world to pay attention to a volcano that has already emptied its own island twice in recent years. It sits on top of one of the most dangerous megathrust faults on Earth, a fault that's been breaking repeatedly in this exact region. And the two hazards, the mountain and the fault, are being driven by the same subducting slab beneath them. That shared engine is real. What is not established, and what you should be skeptical of if you see it claimed, is that the eruption is about to trigger the Great Earthquake, or that an earthquake triggered the eruption. The stress an ash eruption puts on a megathrust is tiny next to the strain that fault accumulates over centuries of plate motion. They share a cause. One does not set off the other. There are three specific things worth watching in the coming days. First, whether Vanuatu's Geohazards Department raises Ambae's alert level beyond 3 and orders another evacuation, and whether that 54,000-foot column holds at stratospheric height or turns out to have been a single violent pulse. Second, whether the Japan Meteorological Agency and the Pacific Tsunami Warning Center confirm, downgrade, or quietly close their investigation into a wave reaching Japan. Third, whether the megathrust under Vanuatu produces any notable earthquakes in the days around this eruption. Because that's what would tell us whether this collocation is anything more than a dangerous coincidence. Watch the alert level, watch the coastlines, watch the column. Each of those answers will arrive on its own timeline, and together they'll tell us whether yesterday was a single violent spasm or the start of something that forces this island to empty out for a third time. This is a volcano and a fault that both demand respect. And yesterday, for a few hours, they showed us exactly why. If you want to actually understand these events instead of just reacting to the headlines when they hit, that's the whole reason this channel exists. Drop a comment with which of the three things I mentioned you think we'll see first: the alert level, the tsunami call, or a new earthquake. And I'll pin the best guesses and follow up when we get an answer. Subscribe so you're here when we do.